Hi, welcome back. We're going to talk about server and application security. No one likes being hacked too, yet most sysadmins, when they hear the word SLinux, their first action is to disable it. It is a real shame, since SLinux is a great security tool in any production level environment. But it is kind of a hassle to maintain. We're going to take a look at AppArmor and its alternative approach to that. We're going to go over some key aspects and a demo to get you started. I hope you enjoy. What are we going to cover? We're going to cover what AppArmor is, alternatives, a bit of history, prerequisites, general configuration. Finally, we're going to do a demonstration and a little word about debugging and a little extra. What is AppArmor? AppArmor is a mandatory access control system. It supplements the discretionary access control system. Sounds complicated? Well, it isn't. A DAC, or a discretionary access control, is the regular access control we're used to in Linux-based systems. This approach means that the user owner determines the permission on the object and can transfer it to other users. The level of permissions is determined by the read, write, and execute model, where each octet symbolizes the permissions assigned. Unauthorized users are basically blind to object characteristics like file size, file name, content, etc. Mac, or mandatory access control, on the other hand, uses a more fine-tuned approach, resulting in an enhanced security. Mac is a bit harder to implement since it has rules and regulations to follow. It can stop viruses from spreading, prevent or mitigate threats, both internal and external. It may even prevent zero-days attacks. You may have heard of SLinux. So what is it? Well, it was developed by the NSA using Linux Security Modules, or LSM for short. An administrator can define a policy or set rules to tell SLinux what can or cannot be accessed. We will usually see SLinux in Red Hat-based systems. AppArmor comes in Ubuntu and SUSE by default. It was supported by Canonical back in 2009 and included in the mainline Linux kernel since version 2.6. It is a Linux kernel security module that allows the system administrator to restrict processes' capabilities per program profile. These capabilities can be file access, networking, socket access, etc. So what is exactly the difference between SLinux and AppArmor? Well, it is a different approach. One key different aspect is that SLinux, for example, uses inodes to identify file objects. AppArmor uses file paths. So a key difference might be if you create a hard link to a file, SLinux will not allow you to access it. Under AppArmor, you might be able to access since it's the same path. Key notes to take from this is please do not disable SLinux or AppArmor if you have issues. Most software vendors or providers will tell you to disable that security feature and it will solve your issues. Well, yes and no. Yes, it works, but you just disabled a key protection in your system. It can be like someone telling you to disable firewall, antivirus, or authentication in a production level system. Back to AppArmor. There are three modes to AppArmor: enforce, complain, disabled. Actually, there is a fourth one. It's called audit mode. It is a mode that is basically enforced, but it logs the events. Enforce is basically to enforce the policy. Everything in the policy is in block mode. Complain is basically a learning mode. It will log potential blocks and allow you to see what would happen if you put it in enforce mode. As far as disabled, well, I think it's kind of self-explanatory. One exception to the complain rule is the deny rule. The deny rule is an exception to that rule because it will still work in complain mode. Deny rules takes precedence over allow rules, and you mostly see them in abstractions. About abstractions, you will see later on. This is used to make sure that you do not create an allow rule that is too permissive by accident. So if you have an issue, you may want to check for a deny rule, since they're also silencing logging. The configuration files are stored under etc AppArmor D. We can see the abstractions and tenable folders. We're going to talk about those a bit later. And we can see the policies are set like a file path, where a backslash is replaced by a dot. Common expressions I'm going to use in our industry standards. Include files are used to pull in parts of other profiles to simplify the structure and prevent doubling our code. Abstractions are basically the same thing. They are a group of statements that are grouped by a common application tasks. Capabilities, well, starting from kernel 2.2, Linux divided the privileges traditionally associated with the superuser into distinct units. Those are called capabilities. Our limits, each resource has an associated soft and hard limits. So entries are set and control application resource limits. Tunables, those are variables. We use them to minimize our static code. A few common commands we're going to use. The enable command is going to see if AppArmor is enabled. The status is going to show us which policies are enforced or complained. The log prof is basically a utility that allows us to update AppArmor security profiles from logging. The clean prof is basically to clean a security profile. It will just remove everything. The teardown will unload all profiles. In order to bring those back, just reload the AppArmor service. The auto dependency will basically allow us to guess which profile requirements we need. To create a new profile, we'll use either the genprof or the autodep. These profiles are going to create those profiles in complaint and not enforced. To set a policy into an enforce, we're going to use another command called aa-enforce. That being said, there are two ways to profile an app: the standalone and the systematic profiling. The first one is used for small applications, while the other one is for more larger enterprise applications with many dependencies. The systematic one is used across reboots, while the standalone is that you cannot reboot while doing the tests. The demo that we're going to be performing is for profiling for a small script. Moving to the fun stuff, the demo. We will create a new application. We will create a policy to match it. Then we will put that policy in enforce mode and try to see if we can tamper with the application to go beyond what we allowed it to do. And then we're going to view logs and do a summary. Let's get started. We're going to start by creating our application. This is going to be a small script to demonstrate the capabilities of AppArmor. This is going to be the greatest script in the world. It's going to show us our current files in our current directory. So we're going to do an echo and use the command ls. Let's save it. And let's give permissions. Oops. There you go. Now we are going to test the application, create a few files just to make it pretty, and create our profile. So genprof and the full path to our application. Now it's going to ask us to do a scan. We're going to run our application. Then it's going to collect all the events and ask us to do things. What we have here is the profile name, the path, new modes, severity, and it's going to tell us what we can do with this. So we have allow, deny, ignore, glob. Glob is basically to change the target path. The glob with extension is to replace the path but leave the extension. New will allow us to create a new rule for it. Audit, abort, and finish. Let's hit allow. And then we have more allows. If we click view, we're going to see something similar to a get. Now let's exit, save, and finish. Now let's see what we got. So let's see AppArmor D and the path. And we're going to see our entire configuration. So if we look, we have include abstractions. We talked about that. Those are pieces of code which are included in our configuration. Then we have the application which has a read, bash, which has an execute on bash on the parent. We also see the permissions on the folder we're trying to do an ls. Now let's see the status of the AppArmor. And then on top, we have our application. Let's quit it. And now we can run our application to test if it works. Awesome, it works. Now we're going to try and tamper with it. Let's add a PS, something we don't have in our profile. Permission denied. Let's try with root. Same idea. So AppArmor allows us to limit the permissions to the exact context we want it to. So this can prevent a lot of attacks, stuff we are not always prepared for. Let's talk about troubleshooting. If we're gonna use AudiD, this does not apply to you. But if you're using the default, you should turn off the limit that the system puts in place to prevent too much logging to occur. Next, we're gonna enable complaint mode on the actual profile we wanna use. Next, we can use logprof to walk over the process events and update our profile. Next, we're gonna reload our profile and we should be golden. Don't forget to reinforce the profile. Finally, let's talk about extras. We should take a look at performance and caching. So systemd analyze blame would probably show you where you have a bottleneck if you have one in a production level environment. Next, this can be a part of a CI. Suppose you are a sysadmin or a DevOps and you create a script or an application or a process. You can make it more secure by attaching a profile to it. This can be a part of a CI by creating a systematic profiling, but you do need to make sure that you go over it manually. The automatic profiling does not give you the best results, so it will not apply any tunables or any kind of abstracts to eliminate doubling your code. Final thoughts are to use this as part of a container. Now, this is a great way to introduce security into your containers. You can prevent other users from attempting to corrupt what you have started. Hopefully, this was educational and you enjoyed. If you have any questions, feel free to reach out to me. And may your day be more secure than the last. See you in the next one.